Welcome to the first lesson in Session 2, Solving Multi-Step Equations in One Variable. Regardless of the number of operations we must perform in order to solve an equation, our ultimate goal is to isolate the variable. Doing so will allow us to determine the possible values of the variable. When performing multiple steps, our goal is to undo the equation. We can do this by performing inverse operations to both sides of the equation, and we'll start by isolating the term that contains the variable. And we'll finish by isolating the variable itself. In our first example, we have 2x plus 4 is equal to 10. The term that contains the variable is 2x. 2x is being added by 4, and then it's equal to 10. Step 1 is to subtract 4 from both sides. This will allow us to isolate the term that contains the variable, and that's going to leave us with 2x equal to 6. Now that we have the term that contains the variable isolated, we can isolate the variable itself. So if we divide both sides by 2, we're left with a value of x that is equal to 3. And we have solved the equation. When solving multi-step equations involving the distributive property, it is helpful to distribute first, then undo the equation. So our example 3 is being multiplied by the quantity of x plus 4 equals 30. We need to make sure that 3 gets multiplied by both x and 4, giving us 3x plus 12 equals 30. And again, we want to isolate the term that contains the variable. So our first step in solving is to subtract 12 to both sides. That leaves us with 3x equals 18. We can now break into the term that contains the variable, divide both sides by 3, giving us an answer of x equal to 6. When equations present themselves with variables on both sides of the equal sign, we want to move like terms to the same side of the equation for easier computation. So 3x plus 5 equals 2x minus 7. Notice we have a variable on the left and a variable on the right. So 3x on the left and 2x on the right. Now it doesn't matter which side of the equation you want to move them to, as long as you get start collecting the variables on the same side. So for our sake in this equation, we're going to subtract 2x from both sides of the equation. This moves the variable to the left side of the equation, and our new equivalent equation is x plus 5 equals negative 7. Now we can solve this equation by subtracting both sides by 5, giving us an answer of x equals negative 12. Now we're going to discuss a few special cases. Sometimes we'll come across situations that have unique solutions. The first example is in a case when we have infinite solutions, meaning that any value that you substitute for the variable will satisfy the equation. 2x plus 4 is equal to the 2 times the quantity of x plus 2, so we would need to start by distributing. Gives us 2x plus 4 equals 2x plus 4. In this case, you can see the left side of the equation and the right side of the equation are equivalent. We'll continue working. Subtract 2x from both sides of the equation to collect all the terms that contain the variable on the same side of the equation. That leaves us with 4 equal to 4. So notice how the variables dropped out of the equation completely. When this occurs, we need to analyze the result. Is what we have left true, or is what we have left false? In this case, the statement that remains is true. 4 does equal to 4. So our answer is infinite solutions. Any value that we plug in for x will satisfy the equation. Sometimes we'll come across situations that have unique solutions. Well, in this case, we'll discuss no solution. 3x minus 5 is equal to 3x plus 2. Again, you'll see when collecting the terms on the same side of the equation, the variables will cancel out. What we have left in this case is a false statement. Negative 5 does not equal negative 2. Therefore, our conclusion is we have no solution. That wraps up the first lesson in Session 2. To earn credit for completing this lesson, you must successfully complete the quiz. Good luck!